If you live in a town or city, your view of the night sky might be something that looks like this. An orange glow fades upwards into the night sky, obscuring all but the brightest stars. You might just be able to make out one or two constellations like Orion. If you can get away from the city lights to a dark site in the countryside, you will suddenly see many more stars. You might even catch a glimpse of the Milky Way, looking like a faint band of clouds stretching across the sky from horizon to horizon. But to an astronomer with the right equipment, the night sky is filled with color and detail. Many thousands of stars can be seen, and suddenly the sky is filled with galaxies, nebulae, and a Milky Way with dust lanes clearly visible. Of course, if you can get to a dark site, an observing session with students can be very rewarding, but you'll still have to make arrangements to carry out your observations and hope the weather behaves. For educational purposes, this makes it very difficult to work with students, simply because you can't guarantee that conditions will be right for observing. This is where having access to a network of telescopes all over the Earth would help. Las Cumbres Observatory Global Telescope is an international research and education project based around a network of astronomical telescopes, located at observatory sites around the planet. The starting point for the educational side of this ambitious plan was the Faulkes Telescope Project, as the LCOGT network will continue to be known in the UK. Officially launched in March 2004 by Dr. Martin Faulkes, a British entrepreneur, the project has its headquarters at Cardiff University in the UK. In the summer of 2005, the Faulkes Telescope Project and its two telescopes became part of Las Cumbres Observatory Global Telescope based in Santa Barbara, California. LCOGT was set up by Wayne Rosing after he retired as Senior Vice President of Engineering at Google. A passionate amateur astronomer with a love of technology, Wayne wants LCOGT to operate a global network of telescopes for research and education. The LCOGT project aims to provide students and teachers with access to research-grade optical telescopes around the world. The main goal is to enhance the teaching of physics, mathematics, information and communications technology, and design technology. Currently, there are two telescopes in the network, one in Hawaii and the other in Australia. The Hawaiian telescope, FT North, is fully operational, and FT South in Australia came online in the summer of 2006. The telescopes are 2-meter class research instruments and are fully robotic, allowing control from anywhere in the world via the internet. In future, users of the network will also have access to several more 2-meter telescopes. As with the first two telescopes, these new instruments will be built by Telescope Technologies Limited, based in Birkenhead in the UK. These large telescopes will form the backbone of the research network. In addition, a further 20 to 30 smaller telescopes will also be built and dedicated to educational use. But why build so many telescopes in so many different locations around the world? To begin with, it means there are always telescopes that are in the dark and able to see the night sky. In addition, if the weather is poor at one site, you can switch to a backup location. In research terms, the network will be able to carry out what we call time-domain astrophysics. This is where a particular astronomical research program is difficult to carry out because of time-related issues. Maybe the event takes longer than a single night or is unpredictable, or there's a need for continuous observations over many days or weeks. The LCOGT network will be capable of all this and much more. This is FT North in Hawaii. The unique clamshell enclosure is specially designed to allow the telescope to be fully exposed to the sky. This permits rapid movement, so the telescope can observe short-lived events like gamma-ray bursts. There are, of course, drawbacks to this sort of design, and the telescope is exposed to the elements much more than a traditional observatory dome. To help reduce the risk of damage to the telescope, a sophisticated weather station is included on site, and additional data is obtained from a variety of other sources. FT North is sited at 3,040 meters above sea level, on the summit of the sacred mountain Haleakala on Maui, one of the Hawaiian Islands. This mountain on East Maui is the world's largest dormant volcano, but evidence of eruptions in the last 1,000 years is still visible at the summit. This dry and dusty environment does not encourage wildlife to flourish, but this species of plant, the silversword, seems to be doing well, growing at altitudes above 2,000 meters. FT South at the Siding Spring Observatory in Australia is in a different environment altogether. At 1,165 meters above sea level, the telescope finds itself located next to the Warrumbungle National Park near Coonabarabran in New South Wales. This world-famous observatory site hosts a variety of large instruments, including the Anglo-Australian telescope. The environment is much wetter than on Maui, but the main concern for those working at this site are the local inhabitants. LCOGT offers many observing programs that schools and other educational institutes can get involved with. These programs give people a chance to do current astronomy research and to work with real astronomers. For example, you can contribute to the Faulkes Atlas of nearby galaxies and measure surface brightness profiles and the lengths of spiral arms in objects that are millions of light years away. Closer to home, you could get involved with the Asteroid and Near-Earth Object program and help the Minor Planet Center in Harvard track newly discovered asteroids in our own solar system. The data will be used to determine orbits, and you might even discover your own asteroid. Studying the life cycle of stars enables you to look at the different stages of stellar evolution, from their birth in massive clouds of gas and dust, right through until they die as planetary nebulae or supernova. You could help monitor current supernovae to produce light curves, or create HR diagrams of clusters of stars. The color imaging program allows you to see astronomical objects in a totally different light. After learning the techniques involved in making color images, you could be producing pictures that rival those from the Hubble Space Telescope. These images aren't just pretty pictures though, as they're crammed with real science data. All of these observing programs and many more come with a wide range of support materials and are led by teams of astronomers and educators. For more information on this and to find out how you can get involved, see our website.